Okay guys, we are going to work our way around the unit circle. This is one of the first written assignments I have you do. Our book doesn't actually introduce the unit circle until chapter 3, but I see that students are a lot more successful if we talk about it early and often. So we're going to go ahead and have you create your own unit circle. We're going to do both degrees and radians, even though you won't start working with radians, like I said, for another couple of chapters. We're going to start working our way around the circle. To do that, you need to remember where the quadrants are. Our first quadrant is at 1 o'clock on the clock, and you number the quadrants counterclockwise. So this is quadrant 1, quadrant 2, quadrant 3, and quadrant 4. In quadrant 1, when I do an ordered pair, both the x and the y are positive. In quadrant 2, the x is negative and the y is positive. In quadrant 3, they're both negative, and in quadrant 4, the x is positive and the y is negative. Now that's going to matter when we start talking about which of our trig functions are positive and negative. We will go ahead and fill those in today, but I don't expect you to remember that information until much later on. So let's go around the circle. Around the circle is 360 degrees. So if I start here at my quadrantal angle in quadrant 1, we're at 0 degrees. My next quadrantal angle is 90 degrees at the vertical positive y-axis. Then I get around halfway around the circle is 180 degrees, 270 degrees, and a full rotation takes me 360 degrees around the circle. Now that I've gone all around the circle from 0 to 360 doing the quadrantals, each 90-degree angle, we're going to go back again and we're going to split those quadrantals in half. So halfway from 0 to 90 is our 45-degree angle, and we're going to count around the circle by 45s. So 0, 45, 90. Then our 45-degree angle that falls in quadrant 2 is 135 degrees, 180. And then in quadrant 3, we have 225 degrees because 180 plus 45, plus another 45 gets us to 270, plus another 45 gets us to 315 degrees, and then we complete our rotation at 360 degrees. Now we're going to go around again to get the rest of our special angles, and this time we're going to count in 30-degree increments. In quadrant 1, we go from 0 to 30. Plus another 30 puts us at 60 degrees, then 90 degrees, 120, 150 degrees. We're halfway around at 180 degrees. Plus 30 is 210 degrees, 240 degrees. Back to our quadrantal down here at 270 degrees, then 300, 330, and we're all the way around to 360 degrees. Now we've worked our way around in degrees. Let's go back and work our way around in radians. A full rotation in the circle is 0 to 2 pi radians. 0 to 2 pi radians. Now, hopefully you know that pi is approximately 3.14, so 2 pi is going to be approximately 6.28 radians. That's how many radians there are in one full rotation of the circle. Well, if the full rotation is 2 pi, that means halfway around the circle is pi radians. And if I cut from 0 to pi in half to get this quadrantal, well, half of pi is literally pi halves. So I have 1 pi half, 2 pi halves, 3 pi halves, and then 4 pi halves is the same thing as 2 pi. Keep in mind we're reducing fractions where we can. All right, so we've done our quadrantals in radians. Let's go back. We cut from 0 to pi in half. Now let's cut this first quadrant in half. Half of pi half, so half of a half is a fourth. So this first special angle that we're going to deal with in quadrant 1 is our pi fourth. That's the same as our 45-degree angle. So we're going to work our way around the circle, counting by pi fourths. So we go from 0, 1 pi fourth, 2 pi fourths is the same thing as pi half, 3 pi fourths, 4 pi fourths is the same thing as pi, 5 pi fourths, 6 pi fourths is 3 pi halves down here at 270 degrees, 7 pi fourths, and then 8 pi fourths reduces to 2 pi. And we've gone around counting by our fourths. Well, if I divided from 0 to 2 pi, or to pi half, excuse me, 0 to 0 to pi half in thirds, 1/3 of pi half, 1/3 of pi half is pi sixth. So our smallest special angle that's equivalent to 30 degrees is pi sixth, and we're going to work our way around the circle counting by pi sixth. So we've got 0, 1 pi sixth, 2 pi sixths is the same thing as pi thirds because it reduces. 3 pi sixths is pi half. 4 pi sixths reduces to 2 pi thirds. 5 pi sixths, 6 pi sixths is just pi. 7 pi sixths, 8 pi sixths reduces. 9 pi sixths reduces. 10 pi sixths reduces. 11 pi sixths, and then 12 pi sixths is the same thing as 2 pi again. That helps me remember how to work my way around the circle and fill in all of those special angles in radians. All right, now let's talk about these coordinates that are still blank on our unit circle. The quadrantals are easy. The unit circle is defined as a radius of 1 unit. So this point on the positive x-axis is 1, 0. My x-coordinate is 1, my y-coordinate is 0. Since the radius is 1, that means that's the largest value I'm going to have all the way around is positive or negative 1. When I move up to my next quadrantal, 90 degrees or pi half, my coordinates are 0, 1. My next quadrantal, 180 degrees or pi, is negative 1, 0. Down here at the negative y-axis, I have 0, negative 1, and then I finish my rotation back at 1, 0 again. When you are memorizing these coordinates, you really only have to remember this first quadrant. The values in this first quadrant are going to apply to the other 3 quadrants for the reference angle from the x-axis. So if you refer back to the x-axis, all you have to pay attention to is whether each of the coordinates is positive or negative. So for the 30 degree angle, or pi sixth, which is 30 degrees from the x-axis, the x-coordinate is longer than the y-coordinate. We've got square root 3 over 2, 1/2 as my coordinates. So for each angle on my unit circle that is 30 degrees away from the x-axis, that's my pair of coordinates. Well, here in quadrant 2, the angle that is 30 degrees away from the x-axis is 150 degrees, or 5 pi sixths. So this angle, in reference to the x-axis, is going to have the same coordinate pair as 30 degrees, square root 3 over 2 and 1/2, with the exception that the x-coordinate is negative because I'm in quadrant 2. When I move down to quadrant 3, the angle that is 30 degrees away from the x-axis when I refer to the x-axis is 210 degrees, or 7 pi sixths. Again, I have the same coordinate pair. This time both x and y values are negative. And I move to quadrant 4, and the reference angle of 30 degrees gets me to 330 degrees, or 11 pi sixths. Still the same coordinate pair. In quadrant 4, the y-coordinate is negative. Now, this coordinate pair for 30 degrees is just switched when I get to 60 degrees. At 60 degrees, the x-coordinate, that value is the shorter value, and the y-coordinate is the larger one. So instead of square root 3 over 2 and 1/2, I have 1/2 square root 3 over 2. And that is going to be the coordinate pair for every angle that is 60 degrees from the x-axis. So my 60 degree angle, in quadrant 2, the angle that is 60 degrees from the x-axis is 120, or 2 pi thirds. So negative 1/2 square root 3 over 2. Quadrant 3, the angle that is 60 degrees away from the x-axis is 240, or 4 pi thirds. So 1/2, negative 1/2, excuse me, negative square root 3 over 2. In Quadrant 4, the angle that is 60 degrees from the x-axis is 300 degrees, or 5 pi thirds. So I fill in a positive 1/2, a negative square root 3 over 2. The other coordinate pair that we have to remember is for our 45-degree reference angles. The x and y coordinates are the same for our 45-degree or pi-4th reference angle. It's going to be square root 2 over 2, square root 2 over 2. X and y coordinates are exactly the same, depending on whether one is positive, one is negative in various quadrants. So the 45-degree reference angle in Quadrant 2 is right here. 135 degrees, or 3 pi fourth, is the same distance, 45 degrees away from the x-axis, so that's my reference angle. Coordinates are going to be the same, except that in Quadrant 2, the x-coordinate is negative. So I work my way the rest of the way around the circle. Okay, the only remaining thing we have to fill in is which of my trig functions, my 6 basic trig functions, are positive and which are negative in each quadrant. Well, my trig functions refer to these coordinates, these x, y, and r values we're going to figure out. But in Quadrant 1, because both x's and y's are positive, that means that all 6 trig functions are positive and none of them are negative. In Quadrant 2, our x-coordinate is negative and our y is positive, so anything that uses the x-coordinate is going to be a negative trig function. Well, the x-coordinate, anything that does not use the x-coordinate is going to be a positive trig function. Sine is y over r, and its reciprocal function, cosecant, is r over y. So those are my 2 positive trig functions in Quadrant 2. The other 4 are negative in Quadrant 2. And again, this part is going to make more sense later on in the semester. You can come back and review the video then. In Quadrant 3, both x and y are negative. So the positive trig functions are going to be those functions that use both x and y. That is tangent and cotangent. The other 4 trig functions are negative. And finally, in Quadrant 4, where x is positive and y is negative, the only negative trig functions are going to be those that use y. If it uses just x and r, it's going to be positive. The trig functions that use x and r are cosine and its reciprocal function secant. So the other 4 trig functions are all negative.